Hi guys, good day. It's me, Teacher MJ. Our topic for today class, it's all about triangle similarity theorem. So without further ado, let's do this topic. So we will be discussing angle, side, and side similarity theorem. And we will give more example class for you to really understand with regards to triangle similarity theorem. So let's start with angle similarity theorem. If two angles of one triangle are congruent to the two angles of another triangle, then the two triangles are similar. So I have here the illustration. I have a big triangle and a small triangle. Different sizes, but the same shape. Now let's label this up. Triangle A, B, C. And the small triangle, let's label this up. Triangle D, E, F. Now according to the theorem class, if two angles of this one triangle is congruent to the two angles of this another triangle, therefore these two triangles are similar. So if we say that angle A is congruent to angle D and angle B is congruent to angle E, therefore these two triangles are similar. If two angles of one triangle is congruent to the two angles of another triangle, therefore these two triangles are similar. So once again, angle A is congruent to angle D and angle B is congruent to angle E. Therefore, we can say that triangle, triangle ABC is similar. So this is the symbol of similar of triangle DEF. Once again, class, be careful in reading the triangle. It must be the corresponding angles, okay? It must be symmetrical, class. You read it A, B, C. So, angle A corresponds to angle D. And angle B corresponds to angle E. Be careful in reading the triangle, class. And angle C corresponds to angle F. C corresponds to angle F. So, triangle ABC is similar to triangle DEF. So, let's give an example for AA similarity theorem. So let's have two example class and you determine if the two triangles are similar. Alright, so let's have an example for AA similarity theorem. Alright, so tell whether the two triangles are similar. Once again, class, I will give you two examples for every similarity so that you will really understand, class, with regards to triangle similarity theorem. So for number one, we have given triangle ABC. Angle C is 90 degrees. We also have triangle DEF. And angle D is 90 degrees. Once again, class, if you have this kind of marking, it means 90 degrees angle. That would be a right angle, class. So this is 90 degrees for angle C, and for angle D, that's also 90 degrees. So we can say that angle C is congruent to angle D. So we already have one pair of congruent angles. So let's locking one for us to check if this is really an AA similarity theorem. So of course, if this is right triangle, okay, we have 90 degrees angle. Once again, class, always remember this one, that in a triangle, the sum of the interior angles, it should be equal to 180 degrees. Once again, class, any kinds of triangle, if it's equilateral, isosceles, right triangle, scalene triangle, any kinds of triangle, class, the sum of these interior angles, if you add these interior angles, it should be equal to 180 degrees. Since we already have 90 and 36, the thing that we will do is we need to add this up and we subtract it from 180 so that we can get this angle. Alright, so this will be, let's add this up, that would be 90 plus 36. So 90 plus 36, that would be 6. 9 plus 3 is 12. 126, we subtract this 126 from 180. So 180 minus 126. So 0 minus 6 cannot be. Borrow 1, this becomes 7. This becomes 10. 10 minus 6 is 4. 7 minus 2 is 5. 54 degrees. Therefore, this angle F, that would be 54 degrees. Alright, and we already have two angles that are congruent, this angle F and angle B. So therefore, we can say that angle B is congruent to angle F. And we already have two pairs of congruent angles. Therefore, these two triangles are similar. So once again, angle C is congruent to angle D. and angle B is congruent to angle F. And angle E is congruent to angle E. Therefore, if this is 5490, angle E will be 36, right? Because 36 plus 54 plus 90, that's equal to 180 degrees. So when you read this triangle, so if it depends on you, class, which do you prefer? So if you read this one triangle, okay, B, AC, so triangle B, then A, then C, is similar to triangle. So once again, angle B corresponds to angle F. So once again, class, angle B, okay, let me just write it here. Angle B corresponds to angle F. Okay, B and F, same angle. And angle A corresponds to angle E. Angle A, okay, angle B and angle F. Angle A corresponds to angle E. And angle C corresponds to angle D. Alright, so if you read this one triangle B, okay, BAC, so you should read this one triangle FED. FED. So be careful, class, in reading the triangle. So once again, triangle BAC is similar to triangle FED. That's it, class. That's the answer for number 1. Therefore, these two triangles are similar. So triangle BAC is similar to triangle FED. That's it. That's the answer for number 1 example. Let's try another example, class, for you to understand this one. Another example. Alright, so number 2, we have given triangle RST and triangle XYZ, and given angle R, that is 48 degrees, angle S is 110 degrees, angle X, that would be 22 degrees, and angle Y is 110 degrees. Therefore, we can say that angle S is congruent to angle Y. So angle S is congruent to angle Y, and we're still lacking one pair of congruent angles. So once again, this is 48, 110. Therefore, to get this angle, we need to add this up, and their sum, we subtract it from 180 degrees. Because the sum of these interior angles, it should be equal to 180 degrees. So we need to add this up, 110 plus 48. So 0 plus 8 is 8, 1 plus 4 is 5, bring down 1. 158, we subtract it from 180. 180 minus 158. So 0 minus 8 cannot be, borrow 1, this becomes 7, this becomes 10, 10 minus 8 is 2, 7 minus 5 is 2. 22. Therefore, this angle T is 22 degrees. And then we can say that angle T is congruent to angle S. Angle T is congruent to angle X. So we already have two pairs, okay, of congruent angles. So angle S is congruent to angle Y, and angle T is congruent to angle X. So once again, if two angles of one triangle are congruent to the two angles of another triangle, therefore these two triangles are similar. Okay? So that would be AA similarity theorem. So therefore, we can write this one as triangle. So if you write this one triangle RST, so triangle RST is similar to triangle. Once again, angle R corresponds to angle Z. Okay? Angle R corresponds to angle Z because they have the same angles. So angle Z must be 48 because 48 plus 22 plus 110, that would be 180. So angle R, so triangle, once again, angle R corresponds to angle Z. So triangle Z, so you read this one RST, it should be ZYX. Triangle ZYX. So angle RST is similar to triangle ZYX. That's it, class. That's it for AA similarity theorem. So let's focus now on SAS similarity theorem. Alright. Now let's talk about SAS similarity theorem. Two triangles are similar if two pairs of sides are proportional and the included angles are congruent. So I have here given triangle ABC and triangle DEF. Now, if the ratio of this side over this side is equal to the ratio of this side over this side, and they have the same included angle, once again, class, the included angle is an angle between these two sides. It's in between these two sides. Once again, the ratio of this side let me just write it here. Line segment AB over this DE, over line segment DE. So let me just check this one. This one, AB over DE. If the ratio of this side over this side is equal to the ratio of this side, line segment BC, over line segment EF, okay? If the ratio of this side over this side is equal to the ratio of this side over this side, okay, they have the same ratio, and they have the same included angle, therefore these two triangles are similar. So we can say that triangle ABC, so ABC is similar to triangle. Once again, be careful in reading the triangles. You read it ABC, so you read this one DEF. Angle A corresponds to angle D, angle B corresponds to angle E, angle C corresponds to angle F. So triangle ABC, it should be similar to triangle DEF. Alright, so that's the thing there, class, about SAS. The ratio of this side over this side is equal to the ratio of this side over this side. Let's give an example, class, for you to understand SAS. I will give you two examples in each similarity theorem so that you will really understand this triangle similarity theorem. Alright, let's have an example for SAS. Alright, so example number 1, we're going to tell whether the two triangles are similar. So once again, in this given scenario, given illustration, we can make two triangles, right? We have the small triangle and the big triangle. So let me just draw this one, class. Okay, so we have, okay, the small triangle and another triangle for the big triangle. So let me just label this up. This is U VX for the small triangle, UVX, and for the big triangle, that will be UYZ. Of course, U will be the included angle because it is in between these two sides. Okay, U is the included angle. From U to V, that is 12. Then U to X, that is 16. So therefore, from U to Y, so U to Y, 12 plus 6, that would be, so 12 plus 6, that would be 18. U to Y. And for U to Z, if this is 16 for U to X, and X to Z, that is 8. So 16 plus 8, that is 24 from U to Z. So once again, the ratio of this side over this side, if it is equal to the ratio of this side over this side, and they have the same included angle, therefore these two triangles are similar. So let's check the ratio, class, if they are equal. So once again, the ratio of this side over this side, so UV, line segment UV over line segment UY, is equal to line segment UX over line segment UZ. So let's check if they have the same answer. So UV, so if they have the same ratio, class, let's check. So UV, that is 12 over UY, that is 18, is equal to UX, that is 16 over UZ, that is 24. So check, class, can we reduce this ratio? Yep, we can reduce 12 and 18, right? Can we reduce 12 over 18? 12 over 18. What would be the GCF, class? The greatest common factor. That's correct. We can divide this 1 by 6, right? The GCF of 12 and 18, that is 6. So 12 divided by 6, that is 2. 18 divided by 6, that is 3. So this will be 2 over 3 is equal to, let's check if they have the same ratio. 16 over 24. What would be the GCF, class, of 16 and 24? That's correct. That would be 8. We can divide this 1 by 8. So 16 divided by 8, that is 2. 24 divided by 8, that is 3. So 2 over 3. Therefore, they have the same ratio. Therefore, they are proportional. So, therefore, they are proportional and they have the same included angle. Therefore, these two triangles are similar. So, there's also another way to check, class, if they are the same. Okay, if these ratios are proportional, you can do cross multiplication, class. Okay, you can multiply this one, but for me, class, it will take time if you do it that way because these are large numbers. But if you have the calculator, class, this will be very easy for you. So you can do cross multiplication, 12 times 24, and if their answer, it would be the same with 18 times 16, so 12 times 24. So once again, 12 times 24 is equal to 18 times 16. Therefore, if they have the same answer, therefore these two ratios are proportional. So for me, it's better to reduce. So they have the same ratio, therefore the sides will be proportional. Alright, so we can say that these two triangles are similar. So we can write this one, the triangle UVX is similar to triangle. So you read this one UVX, so you will also read this one UYZ. So UYZ. Be careful, class, in reading the triangles. That's it, class. This is the answer for number 1 example. Alright, so example number 2. Once again, we're going to tell whether the two triangles are similar. So in this given illustration, we have two triangles. So we have the big triangle, triangle DEC, and triangle ABC. So once again, this angle right here is what we call the included angle. Question, are they congruent? Yep, they are congruent because these are vertical angles. Do you still remember, class, vertical angles? So vertical angles are formed by two intersecting lines. If two lines intersect to each other, they form vertical angles, and vertical angles are congruent. So this angle right here is congruent to this angle, and this angle right here is congruent to this angle. So this is what we call, class, vertical angles, and vertical angles are congruent. So therefore, this angle right here is congruent to this angle. And this is the included angle because it is in between these two sides. Between these two sides. Alright, let's check if the sides are proportional. So, once again, this line segment DC over AC. So the ratio of this side over this side. And the ratio of this side over this side. So, line segment DC over line segment AC. So, once again, class, you check. Okay, the corresponding side DC corresponds to AC over AC is equal to line segment EC over BC. Alright, so DC, that is 21, over AC, that is 14, equals EC, that is 15, over BC, that is 10. Can we divide 21 by 7? Yep. And also 14. So 21 divided by 7, that is 3. 14 divided by 7, that is 2. How about 15 and 10, class? What would be the GCF of 15 and 10? Can we reduce this one? Yep, 15 divided by 5, we can reduce this one by 5. 15 divided by 5, that is 3. 10 divided by 5, that is 2. So therefore, they have the same ratio. Therefore, this is proportional. So 3 over 2 is equals to 3 over 2. So once again, you can do other way. You can cross multiply. So you multiply that. 21 times 10, that is 210, is equals to 14 times 15, that's 210. Therefore, these two ratios are proportional. Alright, so they are proportional and they have the same included angle. These two angles are congruent. Therefore, these two triangles are similar. So you can write this one, triangle DEC is similar to triangle. Once again, class, be careful in reading the triangle. You read this one DEC, and this angle D corresponds to angle A. So DEC, it should be ABC. Similar to triangle ABC. Alright, so that's it, class. Example number 2. I hope you get this one for number 2. So, let's proceed now to SSS Similarity Theorem. Let's talk about SSS Similarity Theorem. If the corresponding sides of two triangles are proportional, then the two triangles are similar. So let's label this up, this big triangle ABC, and the small triangle, that would be DEF. Now, if the ratio of the side AB over DC is equal to the ratio of side BC over EF and side AC over DF, therefore, these two triangles are similar. Once again, triangle 1, this first triangle, that would be AB, line segment AB corresponds to line segment DE, is equal to, that would be line segment BC over EF. So, triangle 1, that would be BC, line segment BC over side BC over side EF, or line segment EF, is equal to this third side. So, this will be AC, so this side over this side, so that would be line segment AC over DF. So once again, if they have the same ratio, the ratio of this side over this side is equal to the ratio of this side over this side and this side over this side. Therefore, the two triangles are similar. So we can say the triangle ABC is similar to triangle DEF. So let's give an example, class, for you to really understand with regards to SSS similarity theorem. And I will give two examples, class. Alright, let's have an example. Alright, so example number 1, you're going to tell if these two triangles are similar. So once again, BA corresponds to side ED or DE. BC corresponds to side EF. And AC corresponds to side EF. Alright, so let's write this one. AB over DE is equal to, so that would be AB over DE, that would be BC. So triangle 1 over triangle 2, that is EF. Okay, line segment BC, line segment EF, line segment DE, line segment AB is equal to line segment AC over line segment DF. And then let's substitute the value. So AB, so we have AB, that is 4, and then DE, that is 8, is equal to BC, that is 5, over EF, that is 10, is equal to AC, that is 3, over DF, that is 6. So for 4 over 8, class, can we reduce this one? 4 over 8? Yep, we can reduce that 1 by 4, right? Can we divide 4 by 4? Yep, we can divide 4 by 4. We can also divide 8 by 4. So once again, 4 over 8, we can reduce this 1 by 4. The GCF of 4 and 8, that is 4. 4 divided by 4, that is 1. 8 divided by 4, that is 2. So this will be 1/2. How about for 5 over 10, class? Can we reduce that 1? Yep, we can reduce that 1 by 5. The GCF of 5 and 10, that is 5. So 5 divided by 5, that is 1. 10 divided by 5, that is 2, is equals to. For 3 and 6, we can reduce that 1 by 3. So 3 divided by 3 is 1. 6 divided by 3 is 2. Therefore, they have the same ratio. Therefore, they are proportional. So these two triangles are similar because they have the same ratio and they are proportional. So we can say that triangle ABC is similar to triangle ABC. You read this one, DEF. DEF. Alright, so let's try another example, more complicated example for this one, SSS, Similarity Theorem. So therefore, these two triangles are similar. Alright, let's try another example. Alright, so once again, you're going to tell if these two triangles are similar. So triangle STU and triangle VXU. So once again, we have given sides. So let's check if the sides are proportional. So once again, this side corresponds to this side. Okay, so this TS corresponds to side VX. So TS, line segment TS over line segment VX. So this big triangle over the small triangle. So this will be first triangle and the second triangle is equal to, once again, the first triangle, this 30 corresponds to this UX. So TU corresponds to UX. This side corresponds to this side. So line segment TU over line segment XU. Okay, XU or UX. So let's just write UX, that's okay. Line segment UX is equal to, so triangle 1, we're done with TU. So we have SU, line segment SU over line segment VU. Alright, and then we substitute. So TS, that is 15, over VX, that is 5, is equal to TU, that is 30, over UX or XU, that is 10, is equal to, okay, so SU, that is 45, over VU, that is 15. So check, can we divide 15 by 5? Yep, we can divide 15 by 5. This will be 3, is equals to 30 divided by 10, that is 3, is equals to 45 divided by 15, that is 3. So you can write 3:1 for the ratio. Okay, 3:1, 15 divided by 5, that is 3. 5 divided by 5, that is 1. So 3:1 for the ratio over 3:1. and then over 3:1. So they have the same answer. So let's just write 3 as a whole number. 15 divided by 5, that is 3, is equals to 3, is equals to 3. Therefore, they have the same answer for the ratio 3:1. Alright, so therefore, these two triangles are similar. Alright, so that's it, class, for AA, for SAS, and SSS. So I hope you learned something new today. If you like this video, do not forget to like, share, and subscribe. You share it to your friends and to your classmates so that we can help more students, especially to those students who are really struggling in solving math problems. Once again, this is Teacher MJ. You have a great day, class. Goodbye for now. Bye-bye.